This lesson's on medians, centroids, altitudes, and orthocenters. We're going to start off by talking about a median, a segment joining a vertex to the midpoint of the opposite side is called the median. When we look at this example, we have the top vertex meeting down here at the midpoint of the bottom line. That actual line drawn there is the median. When three medians of a triangle intersect, they intersect at a point called the centroid. The important part of the centroid to remember is something called the rule of thirds. So, when we actually are looking at this, we actually have three different segments made up with these medians. We're going to have the short part, the long part, and then the entire line. If we just look at this example here, we've got BF. If we break it down, we have the short part here, PF, the long part here, BP, and then the entire line was BF. I'm going to move this over here towards the right so we can see it a little bit closer. Now my short part, FP, is this length. We're going to refer to that as just some number, so we don't really have an actual value, so we're going to say that that is X. Now, we're going to now look at the long part. The long part would be this long if I just actually took that length and put it here. Okay, so we don't actually have a number for that, but we actually can relate it to the short part. If I take my short part, move it down, right, it looks close to being exactly half of there. But we can actually do it one more further. We can actually take that line again and then slide it over, and look, it overlaps it exactly. So we have two of the short parts making up that long part. So since the short part is x, this would be 2 times x, or we could just say it is 2x. Now, our whole line was both of those segments added together, correct? So we have the x plus the 2x, which gives us a total length of 3x. So this is a very key rule when we're talking about the centroids. We're going to use that whenever we're doing certain problems. Now let's look at some practice of this actually. So again, we're going to have the practice on the rule of thirds. We're going to be either given the short part, the long part, or the whole line. Again, the rule of it is the short part is represented by x, the long part is represented by 2x, and the whole line is represented by 3x. So the first one we're going to look at, we're going to say that the short part is 24. So this is very straightforward. If we're trying to find how long the long part is, we just have to take 24 and multiply by 2. That gives us 48. And then if we have to find the entire line, we can take 24 and multiply by 3, which ends up giving us 72. Now, for the second example, we're going to give the whole line is 27. So 27 equals to 3x. Okay. Now, the key on these is if you're given anything besides the short part, which we know is x, we need to first go up and finding what x would be. So I need to go from my whole line back to my short part. So in order to do that, I've got to go from 3x to x divided by 3. 27 divided by 3 would give me 9. Now, to find my long part, that's very simple. Going from the short part to the long part, we just have to multiply by 2. So 9 times 2 gives us 18. Now looking at example 3, we're going to start off with the long part given us as 45. So we're given 2x is 45. We need to go back to our short part, so we're going to divide by 2. Now the problem is 45 does not divide evenly, so we could either have a decimal or we can leave it as an improper fraction. I personally prefer an improper fraction because it just seems to look nicer than having a bunch of decimals on the page. Now, the problem is we still need our entire line. So we could technically add these two parts together, or we could just take the short part and then multiply by 3. So this would be 3 times 45 over 2, which is actually 135 divided by 2. So, again, the rules with it, you always want to get back to your short part and then use the short part to find the other parts that you're missing. The first example we're going to look at does not actually apply the rule of thirds. We're talking about number 1. If P is a centroid of triangle JKL, JK is 22, KN is 13, and OL is 18, we're finding the missing measures. So none of these measurements are actually on our medians. So the rule of thirds does not apply here. But what we do know on this one is that since it's a median, all three sides are split in half. So when we're finding Km, well, we know JK is 22. Km has to just be half of that. So that would be 11. So that would be your answer for Km. When we're looking for NL, NL is on the same side as KN. Those two segments are congruent, so that means that that would be 13 as well. So that is our answer. When we want to do KL, we just combine both 13s, gives us 26. And when we find JO, those two segments are congruent at the bottom, so JO is 18. And JL would be the entire length, so we just double that, 36. Now let's look at example 3. It says G is a centroid of triangle ACE. AG equals to 8, GF equals to 7, and BG equals to 5. We're finding each missing measure. So the first thing it wants us to find is GD. So if we look at this, these are all on the medians. The GD is dealing with this now blue median, AD. Right, so the one that we're given on that line is 8. 8 happens to be the long part of our median, which means we're finding GD, which is the short part. When we go from the long part to the short part, we divide by 2. So GD has to be 4. The next thing it wants is AD. So since I have both of these parts, I could add them together and give me 12. Or I could just do 4 times 3, which gives me 12. The next question wants is C, which is CG. So CG is on this line here. All right, we're given CF, which happens to be our short part. CG is the long part that we are looking for. So in order for us to go from our short part to our long part, we would end up multiplying by 2. 7 times 2 is 14. There's your answer for CG. Now, the next one is asking for GE, which is on the median BE. So, GE is the long part of that median. We're given that the short part is 5. So going from short to long, we multiply by 2. Gives us 10. GE is 10. BE is just the entire median, so we could add them together, or we could do 5 times 3, which would give us 15. And there's all of the missing values for number 3. Now let's look at number 5. On number 5, it tells us that DH is 51. It tells us that GF is 60, and EI is 57. So these are all the entire lengths of these medians that were given. Okay, so the first thing it wants us to find is DJ, which is on the median DH. Okay, DJ happens to be the long part. So the first thing we want to end up doing is finding what the short part would be. Since DH is 51, we have to divide the entire length by 3 to give us JH. 51 divided by 3 gives us 17. Now, to find DJ, we have to end up doubling that, which is 34. So 17 times 2 is 34. That is our answer for DJ. B wants us to find JH, which we already found, so we just put that answer in there. 17. The next one wants GJ, which is on the segment GF. Okay, GF or GJ is the short part of the median. The entire line is 60. So we're going to do 60 divided by 3 to give us our short part, which is 20. So GJ is 20. Next thing once is JF. So we have to take that short part, multiply by 2, which is 40. So JF is 40. EJ is on the median EI. EI is 57. EJ happens to be the long part. So first we need to find the short part. 57 divided by 3 gives us 19. Double that to give us 38. That is what EJ would be. And the last one was JI, which we just found as well to be 19. Now we're going to look at the altitudes. An altitude is a segment joining a vertex to the opposite side so that it is perpendicular to that side. What an altitude really is going to be mostly important for is whenever you're finding the area of a triangle, because we're always going to use an altitude when we're finding the area of a triangle. Now, our altitudes can be in either inside the triangle, outside the triangle, or on a side of the triangle. So this first example, if we wanted to draw our altitude, we would just draw a line going straight down through here, and notice that that altitude would be inside the triangle. On this next one, this is the obtuse triangle. We actually have to extend this bottom line further, and then we have to draw the line going straight down to be perpendicular to that line. Now that altitude is outside of the triangle. And in the third triangle here, we have a right triangle. The altitude is just that side going straight up and down. Okay, that would end up making it perpendicular there. Okay, the orthocenter is where the three altitudes intersect. Now, not really that much whenever we're going to be using the orthocenter right now, so there's not really rules for it. Just remember where the three altitudes meet is the orthocenter. Now, to review these four centers of triangles that we've talked about, the three perpendicular bisectors of a side or of the sides of a triangle intersect at the circumcenter. The three angle bisectors of a triangle intersect at the incenter. The three medians of a triangle intersect at the centroid, and the three altitudes of a triangle intersect at the orthocenter. A circumcenter is equidistant to the vertices of a triangle, and an incenter is equidistant to the sides of the triangle. Now, looking at this, we end up having this chart that I gave to you that has every single thing that we're going to talk about and we've talked about with these circumcenters, incenters, centroids, and orthocenters. I want to make out the point about which triangles end up being congruent, if there are any triangles congruent on these ones. So, the congruent triangles are going to be notated by these arrows pointing to the two triangles that would be congruent to each other. So the circumcenter, again, splits the sides, is congruent to the angles. We also have talked about that the triangles on each side have to be congruent to each other. They're just mirror images of on that perpendicular bisector. So again, these triangles have to be congruent on the circumcenter. On the incenter, it splits the angles and is congruent to the sides. The triangles on each angle are congruent to each other. The centroid has no congruent triangles. And then the orthocenter also has no congruent triangles.